Okay, hello everybody. How are you? How has it been so far? Having fun? We're towards the end of the conference. Um, Usually when I come to this talk, I expect an empty house, but I see that people are interested in testing. So by a raise of hand, who's using testing library? Great. Okay, cool. And who actually knows how it works? Okay, so we have one. Cool. Aviatar, you can leave. Before I introduce myself, I want to start with a short story. I promise it will be short. So once upon a time, it was 3 years ago, I was looking to make my first contribution to open source at all, never contributed before. I decided I'll go with testing library. I'm using the library quite a lot, so this should probably be a good opportunity. I was browsing through the issues, and suddenly I found an interesting one. The issue was a fixed build for React Next. And before I dive into this one, let me just explain what does it mean. In React Testing Library, we're running in our CI 3 versions of React, our testing against 3 versions of React. One version is the current version. We also run against the next version, and we run against the experimental version, because we want to know that if React has any changes, we're not failing because of those. I decided I'd look into it. It was a complicated issue, and it was involved with scheduling the new React scheduler. It was React 17 at the time. I think it was around 2020. So I worked hard. I debugged React Testing Library, and I debugged React. And a few days later, I had a fix ready. It was reviewed and merged around 8 p.m. And I remember that time quite clearly because it was a fun day. And still high on the adrenaline, I went to sleep in a good mood, thinking what could possibly go wrong. After a good night's sleep, I woke up happy, cheerful for making my first meaningful contribution. I made my coffee, sat on my desk. Suddenly, I entered GitHub and I saw this. 10.4.4 causing timeout issue with use effect plus just use fake timers. Type error, cannot read property version of undefined. Schedule function is calling normal priority as a function rather than a callback. So all of these 3 issues were related to my changes. They even contain code that I wrote. And this is not an illustration. This is actually what happened the morning I opened my laptop after making this contribution. And this is an illustration of me right after that happened. But instead of giving something to Stephen Hawking, I gave it to Kenzie Dodds. Okay. Luckily for me, this happened around the time React Testing Library had around 1.8 million weekly downloads. Does anyone know how much weekly downloads we have now? Can guess? Okay, we have around 8.3 million weekly downloads. That's quite a lot. And in this talk, I'm going to try and give you some context about how testing library works, so you won't make the same mistakes I did when I tried to make my first contribution. And don't forget about this story. We'll probably get back to it at the end of the talk. A few words about me. So formally, officially, nice to meet you. My name is Matan Borenkraout. This is me in better days. And this is a picture of my dog when I was packing for this trip. I'm a senior software engineer at Microsoft, and today I'm here wearing my testing library maintainer hat to explain to you how does testing library actually work. This is my site where, to be honest, I'm basically writing for the draw. I had analytics. I saw that there were 5 views a week. I decided to drop the analytics. I don't want to see these. And this is my Twitter handle, or X handle. I updated the logo, but I can't say X. Cool. So before we start, what is testing library? So testing library is a set of simple and complete testing utilities that encourage good testing practices. And our API aims to answer this guiding principle. The more your tests resemble the way your software is used, the more confidence they can give you. This was said by Kenzie Dodds. It's quite popular in testing these days. A few more statistics. DOM testing library, which is our core package, has around 12.7 million weekly downloads. And as we said before, React testing library has around 8.3. In order to understand how we've built this popular package, let's take an example using React and React testing library. Who's developing in React? Cool. So you'll probably understand it's fairly simple. but let's give it a try. Besides that, we support more than 10 frameworks. So it means Angular, Vue, Svelte, and many more using something we call a framework wrapper. This is our component. It's a counter component. It shows the number of coffee cups I drink. I try to stay around 2 a day, but this counts until 6. Whenever we click on the plus, it increments the counter. Whenever we click on the minus, it decreases the counter. And we also have a slider with values between 0 and 6. Are we good? Yeah, cool. This is the code for this one. Let's go over it line by line. So in the first line, what we have is a state, and we initialize the state with the value of 0. Right after that, we have an on-click handler where we actually increment or decrease the counter. Right after that, we have our range input, our slider, where we have a min value of 0 and a max value of 6. We also have an on-change handler that sets the count based on the actual number. We also have 2 buttons, a button with a plus and a button with a minus. And we have an output element. The output element actually prints the current count. OK? Cool. So let's write a test, a simple test that verifies that this component actually works. In the first line, what this test tries to verify is that whenever we click on the plus, the value of the counter is indeed incremented. On the first line, we render the counter to some environment, and we'll soon understand which environment and what does an environment even mean. Right after that, we're looking for an element with the role button and the name plus. Okay? After we have that button in our hand, we simulate a click using fire event, and we verify that the status, the actual count, has the value of 1, meaning it had 0 before and now it has 1. This is a fairly simple test. And as I said, we're using render, but where do we render to? What does it mean render? Where do we render? So the default environment for test runners is usually Node. And when I'm saying test runners, it can be vtest or it can be Jest, whatever you decide. I'm not forcing anything. And the problem is Node doesn't have a window object, okay? And since we're UI developers, we need a window. The Node environment only has a global object. The global object doesn't contain all the functionalities that the window object has. And that's probably a problem. As we said, our components use window functionality. So we need a window. I present to you test environment JS DOM. You probably all have it in your Jest config. If it's not JS DOM, it can be Happy DOM, whatever you decide. And what this line actually does is it gives everyone, as Oprah says, everybody gets a window object, okay? Whenever you have this line in your Jest config, automatically you get a window object with all the functionalities. And we're writing JS DOM. But what is JS DOM, okay? JS DOM or Happy DOM. Happy DOM is the new kid in the block. It's 4 years old. 4 years old in open source is not a lot, to be honest. And JS DOM was actually invented or created on 2015. JS DOM and Happy DOM both are JavaScript implementation of the DOM. And the problem with them is that they don't contain all the functionalities that an actual browser contains, meaning that they don't have navigation and they don't have layout. And what does that mean? What does it mean that they don't have layout and they don't have navigation? This is a fairly popular Stack Overflow issue, and I'll go over it because I'm not sure if you can see at the back. I'm trying to test my anchor tag. Once I click it, I want to add, I want to see if the window location href is what I expect. Okay? Any of you try that in a test? Nobody? Okay, so this doesn't work, and it's not a testing library issue. It's a JS DOM issue. Whenever you click on an anchor, the location doesn't change because they don't have that functionality. So this is the first one. And the second one, we said that there's no layout. What does it mean that there's no layout? This is our component. This is how it looked like. If we don't have layout, it means that all of our elements are positioned at 0x and 0y. And they don't have any display, block, inline block, flex, grid. None of that are implemented in JS DOM. Okay? So all of this can't be used in JS DOM or Happy DOM, whatever you choose. The other problem with JS DOM and Happy DOM is that they are slower than browsers. They are both implemented using JavaScript, and browsers are implemented in a lower level. It means that they are very, very faster. They are faster, sorry. For example, query selector all in JS DOM with an attribute takes 4 milliseconds, okay? And we'll see how we're using that in testing library. Besides that, the goal of JS DOM and Happy DOM, it's written almost line by line. The goal of the project is to emulate enough of a subset of a web browser to be useful for testing. They also do scraping, and they do many more stuff, but they want to say that they're only implementing a subset of the capabilities, okay? And in fact, they are very, very slow. Testing library can also be used in browsers, as long as we have a DOM. The examples for this is Cypress testing library, and it can also be our testing playground. If you haven't used testing playground, it's our Chrome extension. It will help you very, very much with suggesting the correct query, okay? So if you haven't used it, I highly recommend downloading it. And now that we know where we render to, it's probably a DOM, JS DOM, a Happy DOM, or an actual browser. What is the implementation of a render? Does anyone know this logo? That one? Cool, not a lot. This is the React testing library logo, okay? And whenever you see a logo at the bottom right, it means that this code is implemented only in that package. It means that it isn't implemented anywhere else. And this is our render function, okay? What we can see here, starting from the bottom, we have the return value. And this is a pseudocode, okay? It's not the actual implementation. I simplified it a bit so it won't be too complex to understand. At the bottom, we have get queries for element. This is what you get when you call render, and you actually get the queries binded to that element. We also return the container, we return unmount function, and the re-render function. Don't look specifically at the implementation, because we're not going to touch that one. What we're doing in the render function is we're calling React DOM client.createRoot with a container. And basically, that's what we all do in index.ts or index.js when you have a React application. You call React DOM client.createRoot, and you give it a container where it mounts to. Right after we have a root in our hand, we save a reference for that root, both the container where we mounted that root and the actual root. And right after that, we call root.render, which is actually React. Okay, it's not us, it's React. We're actually rendering a root. And we can see that this specific function is wrapped in an act function. Who knows what act is? Nobody? Cool. So act is a utility, but it's a React utility. It's not implemented in React testing library. It's implemented in React DOM. The purpose of act is to ensure that all effects and interactions are flushed, meaning that once you click on an element, all of the effects, use effect, passive effects, whatever happens, is flushed, and the DOM actually emulates what the user sees. We in testing library wrap every interaction you do with act for you. It means that you don't need to write act. And if anywhere in your test you write act, that's a problem. That's probably an issue. You should write it up and open it for us. Act returns a deniable, and we decide whether to await it or not. We have our own specific logic. And probably, that's a spoiler, in our next major of React testing library, you will probably need to await every function, even the render function. Let's see an example of what it means to not use act. This is a counter component. It's a very simple one. All it has is a state with an initial value of 0. And in a use effect, we call setCount. The use effect has an empty dependency array. It means that it will fire once the component is mounted and only once. This is the test we have. And we're looking to see that the component renders with a value of 1. Sorry. And you should look that we're using React DOM client, meaning that there's no React testing library here. It's just React. Who thinks this test will pass? Nobody? Okay, let's go and see what this actual test does. It renders a component, and it tries to assert that the container has the value of 1. This test fails, okay? And the reason it fails, let me get back to the actual code. The reason it fails is that nothing waits for the use effect to actually happen. Our test runs synchronously, and we render the component, and right after that, we assert on the value. And since we haven't awaited for the use effect, which is quite asynchronous to actually trigger, it means that this test fails. This is the correct implementation, and this is what we do inside testing library. We wrap the render in act, and now this test actually works. Cool. So this was render. Not that complex. Let's have a look at get-by-role. And get-by-role is our complicated query. It is also our recommended one, and we know that there are issues with it. Okay, performance issues, you're probably also experiencing that. Let's try and understand why it takes so much time. This actual query lies in DOM testing library. And DOM testing library is our core package, and it can function whenever there's DOM. It means that it can run everywhere. This is the query we want to run. We want to get the elements with the role of button and the name plus. As I said, the by role query is our most powerful query because it heavily relies on the accessibility tree. And this is the accessibility tree. It's a screenshot of the Chrome DevTools, and we can see what we have here. We have roles, okay? We have heading, we have slider, we have button, status, and another button. But we haven't defined those roles explicitly, okay? They were defined for us. So let's get back to the specification to understand how that actually happens. So what's a role? The roles are defined by the World Wide Web Consortium, which is the W3C. And this is the group that actually writes the specifications for the web. In testing library, what we're doing is we're heavily relying on ARIA, which is the Accessible Reach Internet Application specification. And what that specific specification says is that role adds semantic information for assistive technologies, such as screen readers and more. And a role can be either explicitly defined or it can be implicitly defined. Let's try to understand what does it mean explicitly defined. Explicitly defined is quite easy, okay? It means that whenever we write specifically the attribute role equals alert, this is what we will get, okay? And this is an example. So how do we in testing library try to query an element by its explicit role? Whenever you write get by role button, we transform it to something else. And this is what we transform it to. It's only a document query selector role with role equals button, okay? This is what's happening here. Under the hood, whenever you write get by role, this is what we're transforming it. And as we said before, document query selector role takes 4 milliseconds to run, okay? In JSDOM. That was explicit role. It's the simple one. Let's have a look at implicit role. What does it mean that a role is defined implicitly? Do any of you know semantic HTML? Cool. Okay, so semantic HTML is actually what defines implicit roles. And here we have an example of a UL and an LI. Does anyone know what a UL role is? Nobody? Okay. A UL role is a list role. Okay, a UL element implies a list role. And an LI element implies list item role. And this is how we get those roles implicitly defined. But how can testing library know what are the roles? It means that testing library needs to hold some sort of a map between the element type and the implicit role. And we do have. So what happens when you write get by role button and the name plus? We transform it to this. Document query selector role, input, summary, and button. It means that all of these types of elements can imply a button role. Input, summary, button. So let's summarize what we have. We have a query selector role with the explicit part, okay, which is the role equals button. And we have the implicit part, which is input, summary, and button. So seriously, get by role is just document query selector role. It's that simple. So it's not that simple. Let's look at the query we have and the JS6 and try to understand if this query, the query that we wrote now, actually answers to what we need. The first element we have, the first part of the query, is role equals button. Do we have any role equals button in this JS6? We don't have. The second part is an input element. We have one input element, so we save that aside and we'll get back to it later. Do we have summary? No, we don't have summary elements. Do we have buttons? Yeah, we have 2 buttons, and we save those aside too. So this is the array that we have after we're querying the DOM. The button actually implies button role. The other button also implies button role. But does input type range implies button role? Do you think it implies button role? Well, I'm sorry to say, but it doesn't. Okay? Input type range doesn't imply button role. It implies slider role. And the problem is that not every input implies button role, as we just saw. And if that's the case, then probably most of you say, then why don't you query this using this one? Sorry. This has to be better. Give me document query selector role, input type button. That will probably give me all the elements that have the implicit role button, does it? So let's play a game, okay? What's the implicit role for input type image? Who thinks it's a image? Okay, we have 2 people, 3, 4, cool. Sorry. Who thinks it's B generic? Nobody. Who thinks it's C button? Okay, we have some people that thinks it's C button. And who thinks it's no implicit role? Okay, cool. So you see how complicated it is? The actual answer is C button, okay? Input of type image is a button. And it means that implicit role is a very, very complicated thing. And building a selector that fit all cases will probably be unmaintainable. So what we do after we have that array, we loop over the elements and we filter them by the actual attributes that imply role button. And after filtering, this is the list we have. We have 2 buttons, one with the plus and one with the minus. But that's not the element that we wanted in our query. We forgot one part, the name part. And the name part is quite tricky. We get around 1 issue a month saying, I've added the name attribute to my element, and I'm not getting the element. Why is that? Testing library, you have an issue. Fix it. This is the actual language that people use in open source. Yeah, so an accessible name is not the name attribute, okay? It can either be implied from the content, which is called name from content, or it can be implied by ARIA semantics, which means ARIA label or ARIA labeled by, and this is called in the spec name from author. So luckily for us, for button elements, the accessible name is implied from the actual content. So whenever we write plus, we get the element. And we calculate the accessible name, okay? We do it for you. And one last thing happens here in the by role query. We need to iterate up the tree to understand if the actual element you're querying for is visible. Meaning, does it have element hidden? Does it have ARIA hidden? Is the display none? Is the visibility hidden? Because if the element is hidden, we don't want to give that to the user, meaning we don't want to return it to you either. And the problem with visibility is that if my parent is not visible, it means that I'm not visible too. So we need to iterate up the tree until we reach to the HTML. If it's not visible, we don't return it to you because the user doesn't see it, and it means that you shouldn't be testing for it either. So let's summarize the by role. The first thing we're doing is we're building a query based on the explicit and the implicit part. After that, we filter out elements that have the wrong implicit role based on our query before. Right after that, we calculate the accessible name or the accessible description if you've used it in your query. And the last thing, we're checking for tree accessibility to see if the actual element is visible to the user. And that's quite a lot, okay? And this is the reason why by role is the slowest of all queries. We're doing a lot of things, but we're doing it probably on an environment or a testing environment that isn't quite fast, okay? So using JS DOM, every query selector takes around 4 milliseconds, and we do quite a lot of those. But that's also why it's the most recommended query. It actually mimics how the user uses our components. After going over get by role, let's do a quick rundown on a fire event. Fire event is a way to fire DOM events, and it's quite simple. All it does is fires the specific event. It's a low-level API, meaning that in most use cases, you shouldn't be using it, okay? You should probably prefer user event over that, and we'll see it in a second. What fire event does is it uses native dispatch event. It's not a function we've invented. It's based on the spec. All it does is return element dispatch event. And we do have some sort of mapping for the event to know if it bubbles or stuff like that, but it's not complicated. And this is fire event. The better option is using user event. User event is a higher abstraction level than fire event, meaning it simulates full interactions. So if you want to click on an element, it first dispatches hover, and only then it dispatches the click. Because the user, before it clicks the actual element, they first hover over the element. And it also adds visibility and interactability checks, okay? Because what's the motivation to click on an element if it's hidden? The user can't do it either. So if the element is hidden, you won't be able to click on it using user event, and you'll get an error. Same goes for pointer events, none, and stuff like that. We do it in user event. One last thing happens in your test, and if your test runner supports after each, we hook into that, and we call cleanup. Cleanup is our implementation, and remember the line we had when we rendered the actual component? Now, what we're doing is we're looping over that array, and we're calling root.unmount, and we do it wrapped in act, as we saw before, and we also call document body remove child in order to remove the DOM, the elements from the actual DOM. This is what happens. Right after your test, we call cleanup for you, and this is what we're doing. Let's get back to the story from the beginning. As you can probably guess, this is gonna hurt. Probably a week after my merge, the entire code was reverted completely. Not a single character remained in the code base, and you know, I can look at it this way and stop contributing to open source at all. And as I said, it happened 3 years ago, but I tried to look at it in a different way. This whole process taught me a valuable lesson. I've been using testing library for almost a year before contributing, and I never knew how it actually works. So by trying to contribute to the core of the package, I broke it. And after this talk, I promise you, you're more than capable to contribute to testing library on your own, more than anyone else which haven't contributed yet. If you want help with contribution to testing library, or you just want to follow the nonsense I write, I'm available in all these platforms, so talk to me. And thank you so much for listening.